there's a lot of content. So if you are not familiar with this reference, this is a famous Australian poem from more than 100 years ago, written by this person when they were 19 years old. But and I'm not really a poetry person, but the words are just so incredibly delightful. I started with droughts and flooding rains because, like, if you're an Australian, you know, your brain immediately goes to this poem. But I'm like, oh, if you don't know the reference, it could sound a little bit dark. Wide brand land for me is also a really famously known sort of thing in Australia. So, as was mentioned, my name is Elena Williams. I am a software engineer. I've learned in the last few days, I am not very experienced with geospatial. I do a range of other open source things. I'm very enthusiastic about it. But I'm very much a software guy. I am not a geospatial guy. Every so often at the many software engineering conferences I go to, you get somebody who's outside of the domain and they give a talk and you're like, oh, isn't that cute? Like, they're just learning all this stuff. I am that guy today. But I'm here to learn, and I am going to maybe look like I don't know about this domain because I am not an expert in the area, so just setting expectations. I'm talking about addressing in Australia with a company called Geoscape. We are not Geoscience Australia. We're a very small company. There are thousands of people working with Geoscience Australia. There's at least half a dozen of them here. They have a booth. Some of the people I care about the very most in the world work for Geoscience Australia. But they do like rocks and stuff, I think. I don't know. We might be like Lynn's. We do addressing, which is a different thing. And what is addressing? It is that everything exists somewhere, every physical thing on our geo-coordinate system that we know. This is a complete digression, but I only learned this recently. It's just so cool, I have to share. There's a different coordinate system for the sky, and you guys maybe all know this, but I only learned it recently and blew my mind. They take it really seriously. Anyway, so naming things that are permanent and made man and terrestrial is generally the definition of addressing. And you know, there's a cultural context too. Different cultures do addressing in extremely different ways. This has evolved for an extremely long time. The names you apply to locations. This is addressing in an Australian context. We have formally named features that we have a shared understanding of. This is the official authority list from the dataset that we produce that outlines the features that we give names to, that we've accumulated over the decades. And you know, like masonettes and car parks and boat sheds and automatic teller machines, things like that. So we use a conventional Western addressing system, which is that the largest area is to the far right and at the far left is the numeric system. It's pretty normal, the same as at Auckland, like it is here in Auckland. So since I've been working at Geoscape, I often get asked, like, oh, how do you make addresses? Like, who names the streets and stuff like that? And this is actually the incorrect question. The more correct question is, where do addresses get defined? And the correct answer is at the local level. The smallest elected jurisdiction level does this. We call them councils. There are about more than 550 of them in Australia who collect this information and they feed it back to the states, and then somebody's got to make a national version of this, and it turns out it's us. The reason it is us is because we are a country that does censuses, and when these were being digitised in the 90s, we obviously needed one big list of all of the places that all the census people needed to go to in the 90s, and when they were preparing for this, all of the states and territories got together, Australia's accumulation of states and a couple of territories, and everyone went, nah, I'm not doing it, and so they invented a new organisation to do this. Apparently there are a few of these that were created. There's a small number that exist in the government. We've since rebranded to Geoscape. We just figured out that the agency is what the A stood for, like minutes ago, because it almost got lost to time. But we are not the government, but we are owned by the government. We have 8 shareholders. They are the states and the federal government. If we were ever to make a profit, we would feed the profit back to the government. It hasn't been profitable over a lot of its history, but we have a really awesome CEO now, and it's pretty nice. But private still. So let's get cracking on making this big address list. So we collect all these different sources, we mush them all together, and they agree on approximately like 2/3, and then they proactively agree on like heaps of them as well, disagree. But this has got like a lot better over the decades that we've been chipping away at this. So the 8% represents proactive disagreement. You might ask what that means. Here is an excellent example. So for the purposes of the council, this is 69 Sydney Road. If that's for the zoning and that's for their rates and so forth. But if you wanted to deliver a letter there or park a car, you would be hard pressed to. So they have an alternative entrance to do so. And so we have this concept called aliasing. So that's obviously an extreme version. But like here on the corners of places, like you want both addresses, the streets on, just, you know, to save confusion. This here is a whole kind of locality, suburb thing that has got an alias address, and this happens to be where I'm from. This is actually right near our offices, and the way we pronounce this word here is the way that the Queen does, and is incredibly offensive to the Kiwi ear, so I'm going to say it only once, because the Queen, when she opened this oval, she called it Manuka Oval, so that's what we call it. I'm sorry. So we also have this concept of primary versus secondary addresses, where anywhere you're going to get any sort of density of housing or so forth, you are going to have units which have the same point location, and the units generally aren't well geocoded, but it's getting better, but it's still not great. So they're not actually where they're supposed to be. So I want to go back to this just for a second. And apparently, and this story could be completely made up, but I was talking to Alex Leith several years ago, the director of this here conference, and apparently he was part of compiling some of these at the council level. And apparently when he was like a bubby geospatial analyst, he did such a good job it was used by a bunch of them. That story could be completely made up. I don't remember it. There was beer involved. But there was a guy... but the thing is that there are no rules. There are guidelines, and if you've ever worked in an environment that has guidelines, you'll know that, yeah, it's chaos out there. The top line is that an address string in Australia can absolutely be ambiguous to parse, but yeah, it's extremely chaotic. So Newtown, Queensland 4305 is like about an hour's drive from Newtown, Queensland 4350. Apparently the delivery companies have a lot of sadness surrounding this. There's a picture of an island in the Great Barrier Reef. But we make a geocoded national address file. We release it quarterly. We're pretty proud of it. We worked really hard at it. It's used extremely broadly. I gave a talk about this at PyCon AU a couple of years ago, and I was one of 3 talks about GNAF, the geocoded national address files, that was happening at that conference. The others weren't Geoscape people. I was the only one. The original GNAF is a bit of a monster because it's got all of the related data stuff, which we love, with that authority file that I was talking about at the beginning, and street suffixes and prefixes and all that hoo-ha. But it's quite onerous to use, so we made a flattened version. Oh, and it's free in the open source sense, free as in beer. But we also have a third version, which is we keep up to date very regularly, which is the work I do day to day now, like releasing things on a very regular cadence with APIs. So the reason why we have to charge money for this is because that's a 3,000 line response for like a pretty normal electoral bound. That's the whole state of South Australia. That is more than 300,000 lines of response. If you know the right response to do, you can get a response that's nearly 1 million lines long. Costs money down the wire. That's obviously going to take time as well, and you can only do that. You can only deliver it so fast by the laws of physics. So now I want to talk briefly about our standardisation process. So I've been working on this team for a bit more than a year, like getting all of our sources together. So this is a nice, tidy map of the diagram of the pipeline that was produced by not engineers, which looks nice and neat. As somebody who works on this day to day, kind of it's a little bit more like that is what it feels like. These are taken out of some architecture diagrams I made myself, where the supply data we get, we ingest constantly, hundreds of supplies. They can be anything. So all of the major geospatial formats we take, they could be at distributed computing scale. through to like tiny little text files or CSVs, or like literally a couple of our suppliers are emails that somebody manually processes, long-term relationships with some of our suppliers. Would it be the case that maybe they might forget to include several million records or a whole entire region? Happens all the time. And we are the people who make sure that we just ring them and say, hey, did you meant to include all of the suburbs of your region? Then we check for all the normal geospatial stuff, so you know that there are actually polygons. We adhere to the rules about a bunch of this stuff. We have expectation around precision. We standardise to our local CRS. We are originally, a lot of it was GDA 94, and we're trying to move to GDA 2020, and that's a whole other talk. We also have to fix a lot of, you know, there are no rules. So we get a lot of geometries that are just like weird, and we have to manage all of that. And the thing is, we have to do it at scale, and it has to be automated. And so we use a great deal of compute to do a lot of this stuff, a lot of software engineering. You know, here's some examples that I just found, like for looking in our kind of history of the kinds of things, slivers and bow ties and all of that kind of thing. And we have to manage it. Big shout out especially to the roads data that we get, because all of the states provide us their own roads data. There's no rules. Some of them provide us lines, some provide us polygons, even like complex features inside the same data set, like roundabouts. They may not connect up, or they may not be managed consistently throughout the whole data set. And we have to fix that in an automated manner. We have to connect up all the boundaries, the borders as well, to make sure that they meet. One of the states, who I shall not name, when we were first asking for roads data, provided all of their roads as a single geometry. We called it the road, which was difficult to search if we were trying to do that. They fixed it now, though. Shall not be named. We're incredibly grateful to the tooling that is provided. We really rest upon this in our code a lot. We returned some patches back to Fiona when there was the big rewrite, because we were using some of the more gnarly side cases of that. So commit back work, help these projects. We love them, we need them. We're very grateful to all of it. Okay, getting ahead of ourselves. This is all of the things that seem to be accumulating this for decades, the stuff we can layer on top of it. So we got, geo coordinates, we got, we can stack on heaps of information on top of that. We've got some roads as would be expected. We can do speed limits as well. We have some land parcels data. Oh, I'm moving really fast. With zoning and easements, as you would expect, sadly we can't make that. A lot of that data is not entirely free, I think, because it's expensive for us to acquire, because of the way Australian planning is done. And also sometimes with the planning data, it will be submitted to us, and then the thing won't actually be built. So then we'll have artifacts in our data set that then we have to be responsible for tidying up as well. That's another responsibility inside of the work we do. What else have we got? So that is more property thing, like actual properties that people own. We do trees, we do tree heights and surface cover. Extruded visualization is quite nice. And we'll be talking more about surface cover in a minute, but we do a fair amount of that. And in fact, we had one of our local telcos use the tree heights to understand where all of their signal shadows were, which is something you can just do because the tree heights are available, and if you know where that is, which is a pretty fun use case. Buildings, been in buildings data sets for quite some time, and many iterations deep. I think we're in version 3 now. We're very close to a version 4, which is the visualizations are getting nicer and nicer on those. We can put tons of stuff, information on top of buildings, depending on how much analysis you want to do to add on to that, because you can just see them from the sky. This is with different roof shapes, which as a nerd I just think is really cool, that you can kind of determine the roof shapes of buildings just by using your brain and some compute. There's also first floor elevation, which is something that's very new this year, actually. First floor, okay, so this is the beginning of talking about some of the newer things that we are actually innovating in. So there's still a long way to go. A lot of change is occurring in this space still. Why does first floor elevation matter and all of this height stuff is because we're really shifting to really, really caring about risk and resilience. And if you know the first floor elevation of a certain address, you can also have a good idea of at a very granular level of its resilience in the case of a flood. And so, this is the kind of nuance we're up to in the 2025. And so you can then know that, this is more resilient than its neighbour. And obviously there's a lot of scope for more that can be done there. Okay, solar. We've been knowing solar panels. This data being appended onto buildings is also pretty old now. They've been doing it for quite a while. We can get a lot of information about solar, like the different kind of, that's FME processes that do this. So not strictly engineers doing it, but geospatial analysts. Of what the different kinds of solar panel types are, and then some estimates around how much power they're generating. They're very good at detecting them now. This can in turn be aggregated in collaborations with other people, and then we can be actually determining, the amount of power output. So a lot of this kind of data that's in the media often has our data in collaboration with others associated with it. It's in the news all the time in Australia, stuff that we have collaborated with very regularly. My favourite solar panel story, though, is how Australia has been very, very slow to pick up solar technology, solar panel technology for energy generation, because we're also really, really good with providing fossil fuels as well. And so we're kind of a bit slow to that party. And the German energy minister came to visit, some time ago when Germany was producing more solar-powered energy than we were. And they were like, well, the very best place in Germany to produce solar power is worse than the very worst place to generate solar power in Australia, but we have made up a lot of ground. The government has put in a lot of incentives. I think we are now the biggest solar power producer by quite a margin, and it's just the curve is like this. Though we are probably going to be the test case for grid management, because the large old power plants do provide a lot of other things in terms of grid stabilisation, and you take that away, and that's extremely problematic. And no country has successfully done that yet. A lot of countries have started without that, and we are probably in the next, very soon, like year or two, going to start being the test case for figuring out how you transition to being primarily powered from renewable sources and what that does to a grid. That's a lot of fun. Okay. On the matter of fun, so as we have the optimised area to put solar panels on is greater than the number of solar panels you need. We found our first one of these a couple of years ago, and then they've kind of been popping up. So there's a couple of car manufacturer logos and written in solar panels. So clearly, whoever was installing solar panels in this area realised that they could do this thing, and then they were like, do you want to do this? So if you look, you can. There are way more of these now. The more you look for them, the more you'll find them. That's very fun. Cool. So that's a lot of what Geoscape does. We do a lot more than that, but we also collaborate with others as well. And some of the collaboration stuff we're doing now is really nice and really kind of cutting edge, because in addition to the energy stuff, we also are really kind of on the forefront of really taking climate change to the face a little bit. So this is the kind of data that we collaborate on. So that is aggregating temperature indexes with regions and what the density of what they're addressing is, which is pretty useful as well. being able to get a very granular idea of where CO2 emissions are occurring. Again, this is work we've done in collaboration. Some researchers inside our data team have done. Obviously, we are famous for our fires and our floods, and as such, we can provide, do collaborate with others for this, but we are very close to these kinds of problems where if developers are doing planning, we can tell them if that's going to be a really rubbish idea. And I think that that's really good and modern and something that there needs to be more of. And coastal risk exposure, so clearly, you don't want to be building a road where there is, risks of exposure that we can identify. Also, all of these these properties that may be in risk areas too, it's good for them to be conscious that that's going to be something that they're going to have to deal with in the near future. But also we're going more rural as well, so we've been engaged with a fair bit of land usage work as well in the commercial sense. And we have customers who are really interested in understanding these, so perhaps, we can be looking at other ways of using the land that might be better and, giving information for regulation of deforestation. I mean, that's a thing that I think is incredibly important, and ensuring that regulation is adhered to and, where it might not be specifically with addresses. Also, a lot of our infrastructure is just exposed. And to, these risks that are coming, and we should be in front of that. So, just going to say, so it comes all together. We have, this is, addressing is pretty, it's pretty simple. I may have been told that addressing wasn't really geospatial when I was talking about this talk, but I think, understanding things like that your address might be sensitive to. Incredibly proud of the Aboriginal lands dataset that we've created as well. And so, your address, you can know your bushfire risk, your flood risk, your local Aboriginal lands, whatever it might be. Oh, well, that's all the addressing that I have to talk about. And, go join your local community, whatever that might be. Oh, my word. Oh no. I'm not scared, it's fine.
You and your chat.
Hi, Alina. Thank you very much. Any thought about opening it up for OSM consumption?
Which part?
All of it? No.
Because there's a lot. I mean, there's just. Yeah. I mean, that's a What do you mean?
So the base level of street addressing and
the addressing. GNF is all there. It's all there. It's already open.
And the waiver's been signed.
It's for GNF is.
So
in what sense do you mean?
With Creative Commons license, there is a clause in there which can be interpreted ambiguously. And in order to use the data in OpenStreetMap, there is a request. The waiver must be signed. Nearly every state government, Geoscience Australia, many organisations have signed this waiver, and some haven't. Has Geoscape?
So who's some?
I don't believe so.
So it's a tiny little detail.
Cool.
So if you release GNAF as Creative Commons, that's awesome. It's fantastic, and thank you. And you do. I think you do, right?
Well, no, I'm not sure of the license associated with it. I haven't checked. I just didn't think to look.
The Geoscape version has a special clause because of Australia Post as well.
Oh yeah, and that might not be us. It might be Australia Post. And we are very limited by what we can do by Australia Post as well. It's not just us.
So I guess what we might do as the community, and sorry to corner you here.
No, I care. I do. I sincerely do. But I'm a software engineer. So
as an OSGeo Oceania board member, we've done this as well. We can campaign on behalf of local chapter for OpenStreetMap.
I will ask the question to our lawyer. I'm very happy to. But it
becomes a political decision inside the organisation, and all you need to do is sign a little letter, so like a form letter to say this meets those criteria.
Okay. And often the answer I get back when I ask questions like that from the engineering department is it's the government, not us, or something, or this other tertiary entity doesn't want to do. We're small and generally very. Obviously, we're commercial, but as far as commercial places go, they're kind of the hearts are in the right place. You know, trying to do work for the forces of good.
Yeah.
Just a quick addition to that, I do think that GMAP is part of overture maps, which is probably.
Yeah, I want to talk to people about that here. The Overture initiative.
I'm afraid I'm going to have to do it. It's 25 past.
Thank you.